Hello everyone, welcome to your next lesson. This lesson is Algebra 1 Essentials Equivalent Expressions. This is lesson 3 of 4, the third of 4 main ideas and main topics that I need to make sure that you know before moving on to the next grade. So let's go ahead and get started. Here are the IXL practice codes that you will be completing at the end of the lesson today. This video is going to be focusing on that first practice code, ZXX. The next video, which is still part of the same lesson, is going to focus on that second practice code. For your grade for this assignment, I will be averaging your scores based on the table that you see here. As always, you choose your grade. You choose how high of a score you want. If you just want the bare minimum, you could aim for that 70. But if you want to show me that you really understand this, then you want to aim for a 90 or 100. Like I said before, this video is going to be focusing on just that first practice code, ZXX. So in this video, we're going to review how to simplify. We're going to practice simplifying expressions with one variable. And then near the end, we'll practice simplifying expressions with more than one variable, multivariable expressions. In the next video, we'll talk about how to identify equivalent linear expressions. That's going to be the next IXL code, but that's later. For this lesson, you will need paper and a writing utensil. As always, I will be asking you to complete some practice problems during this lesson. Calculators are optional. The most that you will need them for is to do some basic addition and subtraction with positive and negative numbers. If you can do that in your head, that'll be better. However, if you feel like you really need it just to speed up your process, that's totally fine. You can use a calculator. And with that, let's go ahead and start with the basics, how to simplify one variable expressions. Take a look at the problem in front of you. These are the type of problems that I need to make sure that you know how to simplify before you move on to another grade. We are being asked to simplify the expression r squared plus 4r plus 6 parentheses 3r plus 3r squared close parentheses. There's a few different ways to think about how to simplify this problem, but in order to do that, we first need to review two main ideas when we're talking about simplifying expressions. The first one that we're going to review is combining like terms. What does it mean to combine like terms? And the next thing that we also need to remember is, what does distribution mean? This problem requires us to do both of those things, but before we answer this problem, let's look at a few other examples that will help us understand these main ideas first. The first main idea that we're going to review is combining like terms. What does combine like terms mean? Well, let's think about each word separately. The word combine can be thought of as putting things together. So to combine is to put things together. The word like means the same or similar. And in algebra, the word term or terms, it means a group of numbers and variables that are separated by addition or subtraction. Let's talk about that word term a little bit more with the two examples that we see below. For this first one here on the left side, we have negative 5m, negative 2, and a positive 7m. So again, if we look at the definition, we have a group of numbers and variables that are separated by here subtraction and addition. So here we have three terms. Negative 5m is one term, negative 2 is another term, and 7m is another term. There's three terms total. On the right side, we have negative g squared, negative 2g, negative 10, and plus 8. Again, each sign right here, the minus and the plus, this separates the terms. So here we have four different terms. But like terms, when we think about like terms, it's a different type of problem. So let's change the definition a little bit. When we talk about like terms, what we're really saying is we're talking about terms with the same variable and the same exponent. So let's look back at the first example on the left side. Here we have negative 5m, negative 2, and a positive 7m. These two right here, negative 5m and a positive 7m, they have the same variable. So these are considered like terms. When we look at the second example, we see that we have a g squared and a 2g right here, and they're both negative. Negative g squared and negative 2g. They have the same variable, they both have a g, but because this one has a different exponent, it has an exponent of 2, and 2g, we don't see an exponent, but it does have an exponent of 1. And because they have different exponents, they are different terms. So now let's put it all together. Combined like terms means to put together terms with the same variable and exponents. For the first example, we know that negative 5m and 7m are like terms because they have the same variable. So we can just combine them. Negative 5m plus 7m. Well, that's just negative 5 plus 7, and that is 2m. Negative 5m and 7m, when we combine them, it's equal to 2m. We still have the negative 2, so we're just going to go ahead and bring that down. Right there. So for this first example, this is your answer. This is how you would simplify it. You combine negative 5m, 7m, it became a positive 2m, you bring down the negative 2, and then that's it. Again, these two terms right here, 2m and negative 2, are not like terms. I cannot combine them because one has a variable and the other one doesn't. They do not have the same variables. They are not like terms. Like we said before, we can't combine the negative g squared and the negative 2g because they have different exponents. They are not like terms. For this example, the negative 10 and the 8 here at the end of the expression, we can combine those. They are just regular numbers and they don't have any variables. So because of that, they can be combined. They are like terms. Negative 10 plus 8, that's equal to a negative 2. Everything else that we have left over, we can't do anything with that because again, they're not like terms. So we just go ahead and bring that down. So here we have negative g squared and negative 2g. And then again, we combine the negative 10 and the 8. So negative g squared minus 2g minus 2 is our final answer. The second main idea that we need to review is distribution. If you remember from class, distribution is just a special kind of multiplication that happens in situations like this. Situations like the 6 outside of the parentheses. Even though we don't see an operation between the 6 and the parentheses, we know that this is just multiplication. So in order to simplify this, we are going to distribute this 6 with everything inside of the parentheses. Again, distribute just means multiplication. We're going to multiply the 6 with everything inside the parentheses. So as our line suggests, we're going to start off by multiplying 6 times 6h. 6 times 6h is 36h. And now we're going to follow the second line, 6 times 2h squared. 6 times 2h squared is a positive 12h squared. The next thing we need to ask ourselves is, can we simplify this anymore? So let's check if these are like terms. Like we said before, like terms have the same variable and the same exponent. And even though both of these have the same variable, they both have h, they do not have the same exponent. So that means that there's nothing else that we can do. This is our final answer. And now that we reviewed these main ideas, now let's go back to the first problem that I showed you, which is right here now. So in order to simplify this problem, we need to determine which of these two main ideas, combining like terms and distribution, which of those do we need to do first? Whenever we're simplifying, we are following the order of operations, which means that according to the order of operations, multiplication, which is in this case distribution, should go before addition or subtraction, which would be combining like terms. So because distribution, multiplication comes first in the order of operations, that's the first thing that we need to do. So we're going to do distribution first, and then we're going to combine like terms. So let's look back at the problem. Here I see a negative 6 being multiplied with 3r and 3r squared. So that's the first thing that we're going to do. 6 times 3r is 18r. 6 times 3r squared is a positive 18r squared. The 18r was also positive, so I'm going to put a plus right there. And we're going to drop down what we haven't touched yet. We still have a positive 4r, so let's bring that down, a positive 4r. And we have our r squared. So now everything was brought down. Now that we distributed, now let's check, can we combine anything? Can we combine any like terms? For this one, I'm going to start off with r squared because there's another r squared over here. Again, they have the same variable and they also have the same exponent. So I could combine both of those. R squared and 18r squared becomes 19r squared. If you're not sure where the 19 came from, well, in front of the r squared over here, there is an invisible 1. And when we're combining like terms, we're just adding the coefficients, the numbers in front of the variable. So we had 1 plus 18, which is 19, since they were both positive. Next, let's just check if there's anything else that we could combine. We have positive 4r, and we have an 18r. They both have the same variable. They both have 1 as the exponent. So, in this case, we could combine them. 4r plus 18r is the same thing as saying a positive 22r. It's time for some practice. Here are 2 problems. I'm going to give you 1 minute to try and complete these. If you need more time, press pause and press play when you are ready to start. Your time starts now. And now it's time to review. Both of these problems are asking us to simplify. However, we're going to answer them in slightly different ways. For the first problem, we see that all the terms, every group of numbers and variables, has t as the variable. All of them have a t. However, they do not all have the same exponent. The first 4, it looks like these 4, all have t squared, but the last one does not. So when you combine them, you're only allowed to combine these first 4 together because they have the same variable and the same exponent. So negative 10t squared plus negative 7t squared plus 7t plus negative 5t. That's what we're trying to figure out. You can just go ahead and type the coefficients into a calculator and add it up that way. I just want to show you another way that you could have thought about this, using this idea of zero-sum pairs. As a reminder, zero-sum pairs are just 2 numbers that add up together to cancel each other out. So a positive 5 and a negative 5, a positive 3 and a negative 3. It's the same number, just one's positive, one's negative. And here we have zero-sum pairs. We have a negative 7t squared and a positive 7t squared. So instead of having to deal with those numbers, we can just go ahead and cancel them out. They're going to equal to 0 anyway. So all we have left over is negative 10t squared and negative 5t squared, which when we combine them gives us a negative 15t squared. And don't forget that we still have a negative 10t that we need to include as part of our answer. So negative 10t. Remember, they both have the same variable, but they do not have the same exponent. So we're done simplifying. There's nothing else we can do. Negative 15t squared minus 10t is our final answer for this problem. For the second problem, we're going to have to distribute first. Remember, multiplication comes before addition and subtraction. So here on the right, we have that 7 being multiplied by everything inside the parentheses. We're going to multiply 7 times negative 3u and 7 times a negative 9. 7 times negative 3u is going to be a negative 21u. 7 times negative 9 is going to be a negative 63. We still have the 8u as part of our problem, so let's go ahead and bring it down. So now our problem says 8u minus 21u minus 63. Now we're going to ask ourselves, are there any like terms? Is there anything that we can combine? If we notice that these first two, 8u and negative 21u, they both have u as a variable, and because of that they are like terms. We can't combine them. 8u minus 21u is going to be 13u, and we still have that negative 63 that we could go ahead and drop down. Negative 63. The last thing we're going to ask ourselves is there anything else that we can combine? And in this case our answer is no. One of our terms has a variable, the other term does not. So these cannot be combined. That is going to be our final answer, 13u minus 63. Here we have a challenge problem. If you want to try this on your own, go ahead and pause the video, try it on your own, and then see if we get the same answer. However, if you'd rather just go along and do this with me, then just go ahead and keep watching. So for this problem, as before, we have distribution that we need to do first, and then we're going to combine like terms. We're doing the same thing. It's just a little more work. So let's look for any distribution first. We have a 10 outside of this parentheses, which means that we're going to distribute that 10. We're going to multiply 10 with 3b and with 10b squared. However, that is not the only multiplication that's going on here. We also have this 6 next to this parentheses, which means that we're also going to distribute that 6 with everything inside. So 6 times 4b squared and 6 times 3. So let's go ahead and do all this multiplication at the same time. We have 10 times 3b, which gives us 30b. We have 10 times 10b squared, which gives us 100b squared. On the right side, we have 6 times positive 4b squared, which gives us a positive 24b squared, and then 6 times 3, which is just 18. We just distributed. Now let's check if we have any like terms. Is there anything that we can combine? We see multiple terms with the variable b, but only 2 of them have a square on top. So 100b squared plus 24b squared. Because they have the same variable, we can combine them, and exponent. 100b squared plus 24b squared, that's the same thing as saying 124b squared. We still have 30b and 18, but because the 30b has a b as a variable and 18 does not, we can't combine them. So let's just go ahead and bring them down. We have a positive 30b and we have a positive 18. And this is going to be our final answer, 124b squared plus 30b plus 18. Everything that we talked about before was simplifying when you only had one variable. What we're going to talk about now is simplifying when you have more than one variable. So this is what I mean. Here you have 3 different types of examples of the types of problems that you're going to see on IXL. Here we are being asked to combine any like terms in the expression. We're also told that if there are no like terms, rewrite the expression. We'll get to that part in a little bit. Okay, so let's look at the first one. Combine any like terms. So let's check what our terms are. For this first one, we have 5y to the power 3 and 9x to the power of 3. So remember, like terms have the same variable and exponent. This example has the same exponent, but the variables, the letters, are different. So because of that, we actually can't combine them. There's nothing that we can do here because they have different variables. So your answer for this is just going to be 5y to the power of 3 plus 9x to the power of 3. The same thing that we started off with. So that is what this means. If there are no like terms, rewrite the expression. So that's what we did. We just rewrote our expression. That's our answer. Now let's check number 2. We have 2q to the power of 3r, and on the other side we have 8q to the power of 2r. So this is the first time that we're seeing more than one variable in the same group. I want to make sure that you understand that this whole section right here, that is considered one term. All of that is being multiplied. You can think about that as 2 times q to the power of 3 times r, but it's all considered to be one term. Same thing for the other one. 8q squared r is also just one term. So now let's check if we can combine them. They do have the same variables. They both have q and they both have r, but there is a difference in their exponent. This one has a 3 and this one has a 2. And because of that, you cannot combine them together. They are not like terms. They do not have the same variable and exponent. It needs to be both. So similar to what we did before, we can't combine them. So our final answer is 2q to the power of 3r plus 8q to the power of 2r. We just wrote the problem again. We can't combine them. That is our final answer. And you might already know what the answer for number 3 is, but let's go ahead and do it together anyway. We have 8bc plus 4bc. They both have b and c. They have no visible exponents on top, so that means that these are like terms. You can combine these. So when we combine them, similar to before, we just combine the coefficients, the 8 and the 4. So 8 plus 4 is 12, and then b, c, we just attach to the end. 12bc is your final answer here. Now it's time to see if that made sense to you. Here are 3 different problems. I'm only going to give you 1 minute, but if you need more time, again, pause the video and press play when you're ready to start. Your 1 minute starts now. Welcome back. It's time to review. Problem number 1. 10st squared minus 3st squared plus 9st to the power of 3. It might sound unnecessary for me to read it out loud, but when you do read it out loud, it's very obvious to see if they are like terms or if they are not. When you heard me say it, one stood out. The one that stood out was the last one, the third term, because this one has a different exponent. That one is different than the other ones. 10st squared minus 3st squared, they both have the same variable and exponent, so I can combine those. That is going to become 7st squared. But we cannot combine that with the other one because the 9st to the power of 3 has a different exponent. So All we're going to do is just bring it down. 9st to the power of 3. And that is going to be your final answer. Problem number 2, 4x to the power of 2 plus 9w to the power of 2, x to the power of 2. They both have x to the power of 2, but the second one also has a w to the power of 2. The first one does not have a w to the power of 2, and because of that, these are not like terms. You cannot combine these together, even if they both have x squared. They both do not have w squared, so you can't combine them. That means that our final answer is 4x squared plus 9w squared x squared. Nothing changed. That's it. And then for the last one, we have 10s to the power of 3 t to the power of 3. Okay, I'm going to underline that just to keep track of my work. 44q to the power of 3 r to the power of 3. So that one is different. That one is not the same. I'm actually just going to go ahead and skip through the problem, and nope, none of these have s to the power of s to the power of 3 t to the power of 3. So I already know that I'm not going to be able to combine this with anything else. So I'm just going to go ahead and drop it down as part of my answer. This is going to be 10s to the power of 3 t to the power of 3. Okay, so we got that out of the way. Let's look at everything else that we still have to work with. So we have one that has q to the power of 3 r to the power of 3 right here. The other ones also have q to the power 3, r to the power 3. And because they all have the same variable and exponent, all of these could be added up together. When you add them up together, 44 plus 25 plus 7 is 76. So here we have a positive 76 q to the power 3, r to the power 3. And this would be your final answer. If you feel comfortable with all the examples that we just reviewed, then you are ready to start the first IXL code, ZXX. As a reminder, this is just part 1. If you want help doing the next IXL code, there is another video after this. Remember, I will be averaging your scores together, so please do your best on both of these skills. As always, if you have any questions, please feel free to reach out to me on Schoology, on Zoom, or whatever, my email. I'm here to help you. Let me know if you need help, okay? See y'all later. Take care. Peace.